Welcome to Beginner-Techies. In this video, I'm going to discuss about binary search algorithm, right? We can call it as half interval search algorithm. The complexity of binary search is O of log n. So if you're talking about searching algorithm, the binary search algorithm is one of the best, one of the most optimized search algorithm. As we discussed in the last video regarding the linear search algorithm and the pros and cons of linear search algorithm, right? There are few pros and cons of binary search algorithm as well. Binary search algorithm will never be work on unordered data set. This binary search algorithm is only specific to sorted data set. So we can say this is one like limitations. If there are unordered data sets, then we should first sort that data set, then we can apply binary search. And binary search algorithm is very efficient for large data set. If we are comparing with linear search algorithm, so linear search algorithm complexity is O of n. Linear search algorithm is not good for large data set, but binary search is very efficient for large data set, right? So binary search algorithm is a search algorithm that finds the position of a target value within a sorted data sets. Draw an example so that we can get a better understanding. Suppose we have this data set, okay, 1 3 5 7 9 11 12 14 17 20 25, okay, and let's suppose target is equal to what? Let me consider target is 5 right now, okay. Now, so the next thing is we need to calculate the mid elements. How can we calculate mid element? First we have to define our L is equal to 0. So we will start from the 0th index, and there should be one more element. There should be one more variable, or size of, this should be size of array length, okay. So now mid element will be calculated by so L plus R minus L by 2. So this way we have to calculate the mid element. We should not use this way because this will lead array index of bound exception. Array index of bound exception. Okay, because the max positive integers size is 2 raised to the power 31 minus 1. If L and R is higher values, then sum of these two values will be negative. That will exceed this 2 to the power 31 minus 1. This is the max positive integer values. Okay. So in some cases this may fail. So that is why the best practice, like we should always follow this way to calculate the mid element, right? Right. So let's suppose L is 0, R is length of minus 1. So what is the indexes here? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So right. So mid is 0 plus 10 minus by 2. Okay. This should be fine. So 1, 3, 5, 7, 9. So sorry, 11, right? So 11 will be the mid element here. So this is the index of mid element. Index of mid element, right? Right. So array of mid is equal to what? 11, right? This is mid. Right now this is mid. Mid will vary, okay? This will change. So right now mid is 11. Now, how binary searches work? First we have to find out one mid element, right? So, let me write here. So the first step is to find out the mid element, right? Now second step, compare mid element with target. So how many cases is there if we are comparing? So if target is greater than array of mid, this is one case. Another case is if target less than array of mid, right? And third case is if target is matched with array of mid. These three conditions we have to take care of while we are going with binary search. Okay. So first we have to find out the mid element, and then we will compare mid element with target if target is greater than array of mid. So now let's look into the example. What is target now? Target is 5. Okay. Target is 5. And array of mid is 11. So 11. So array of mid is greater than target, right? 5 is target, 11 is mid element, right? So if 11 is greater than target, then we have to always look into the lower part of the middle element, right? This is the lower part. So let me write here. We have look target into lower part of mid element, right? And here it is just need to check in upper part of mid element, right? Here we can simply return if it is match. Sorry, it is match. Return mid, right? This is the index, right? So here if we see 11 is if array of mid is greater than what? Array of mid is greater than target. If this is, then what we will do? We have to update this L value with what? Mid minus, sorry, in this case, this R will be updated with mid minus 1. So what was the mid? Mid was 5. So R will become 5 minus 1 is equal to 4. So the new updated data set will be till 4 we have to find. So the new updated data set will be 1, 3, 5, 7, 9. Now we have to again calculate the mid element. So what is low? What is L here? L is still 0. And what is R? R is 4. And 0 by 2 is equal to 2. So 0, 1, 2. So mid will be 5. Now again we will compare. So here target is 5 and mid element is 5. This is the mid index. Mid index, okay. And sorry, this is array of mid. Okay, this is array of mid. So here if both are like target is matched with mid element, then we can simply return the index. So in this case the result will be 2. So here fifth is available at 0, 1 to second position, right? Similar way, if we are if we have target is 17, we have to find out the 17. Okay, so what we will do, right? So in this case we have L is equal to 0. r is equal to what? 10. We have to calculate the mid. So mid will be what? Mid will be 5, array of mid 11, right? So these are the initial values, and the target is changed now. Target is 17. So now we will compare with if target greater than array of mid. So array of mid is what? 11, right? So 17 greater than 11. In this case, what we will do? In this case, let's look up into the input. So here 11 is mid element, right? And 17 is greater than 11, mid element, right? Greater than mid element. So it means like our target is always reside into the upper part of the mid element, right? So this is the upper part. So in this case, if this is the, in this case, L will be updated. Earlier R was updated, here L will be updated. So L will be mid plus 1. So what is mid? Mid index is 5, 5 plus 1 is equal to 6. So we will consider these data set now. So from 6 to 10, the updated data set is what? 12, 14, 17, 20, 25. 12, 14, 17, 20, 25, right? Right. So this will be the data set. And now again we will calculate what? Mid element. So how? So mid element here L is 6, right? And what is R? R is 10, right? And minus 6, by 2. So 6 plus 2, 8, right? So at 8th index, we have our mid element. So if you consider this is the mid element, right? 17. Okay. So array of 8 is equal to 17 from this. Okay. Now again we will compare. So our target is equal to array of mid, right? So we can simply return what? Mid index. Our target is found at this position, right? So this is the like this way we can simply write the binary search algorithm to find out any items from the data set. Okay, so let's run this problem into the Eclipse. Okay. Binary search, I'm creating the class as iterative because we will check with the recursive approach as well. So this is the iterative approach, binary search iterative. Okay. So here I'm adding the array one, 2, 5, 7, 9, 11, 13, 14, 15. Int target is equal to 5. Okay. Get target. So array and target I'm passing int right. So here we will define two variables, int low is equal to 0, int high is equal to array dot length minus 1, right? While low less than high So we have to find out the mid element. So we can define here itself. This will be changed every time. So low plus high minus low by 2, right? So if mid is equal to, sorry, if array of mid equal to target target, we can simply return the mid. Else, if target is greater than array of mid, if it is greater than array of mid, then what should we do? We have to, if target is greater than mid, okay, so in this case low will be mid plus 1, right? Because we don't need to check lower part of the mid element, right? We have to always check into the higher, or else we have to high is equal to mid minus 1. So if target is less than array of mid, then we don't need to check upper part of the mid element, right? Or else return minus 1. So if index not is equal to minus 1, system dot sysout, sorry, target found at index target right? Let me run this. Let me run it again. Right, so target is equal to 5 found at position 2, 0 1 2, right? So 5 is we have found the 5 at position 2. Let me change it. I'm making target as 14. Okay, so target 14 found at 7, 0 1 2 3 4 5 6 7, right? So this way we can find out the target element from the large data set. Okay, right. So this is the template. We can solve any we can solve any binary search problem with the help of this this template. So here we can use binary search when searching is required over the large sorted data set. So binary search is only applicable for sorted data set, as we discussed. And below are the few examples which can be efficiently solved using binary search over the sorted data. Like these kind of problems we can solve using binary search algorithm efficiently. Next smallest elements, next largest element, nearest keys, smallest element, largest elements. And there are so many problems like which is with the help of binary search algorithm we can efficiently solve. So in the next video we'll in the next video I will discuss about the hashing technique. how the hashing technique is better than binary search algorithm. And so if we are solving this kind of problem with the hashing technique, then that will not be a good approach. So we'll discuss in the next video, and we will solve these kind of problems with the help of binary search algorithm in next couple of videos. Thank you for watching. Bye bye.